The next topic I want to cover is tool radius compensation. And before we actually use it and implement it, it's important to understand that there are two ways to do radius compensation with the tool. One is called contact contour and the other one we call cutter compensation. And with these slides I will try to explain the difference. Contact contour is the mechanism that you will primarily find in Europe. Here's basically the methodology is that the toolpath or the coordinates that you find in the ANSI program actually represent the contour that you actually want to have. So in the ANSI program you can see the dimensions of the workpiece that you're going to machine. And if you want to use radius compensation of the tool, the toolpath that the machine tool actually produces, the tooltip path, that is actually offset, in this case left of the contour, and this path is offset by the controller by the radius of the tool, and in this case it's offset by the actual radius of the tool. So if you have a tool that is a little bit smaller than what you originally have in mind, you have to enter the actual dimension of the tool into the CADCOM register of the controller. So that's one way of approaching it. Another option to approach that is to program with a certain tool in mind in the CAM system. So for example, you program with a tool that has 10 millimeters diameter, and already the CAM system offsets the tool path from the part. So the tooltip or the coordinates that you see in the ANSI output are the red line, and they are already offset by the CAM system. And if in reality you're using a tool that does not have the 10 millimeter radius of our ideal tool in the CAM system, but if you're using a tool that is typically smaller because of wear, then the controller has to offset by this wear value towards the part. So in this case, right of the programmed red curve. So these are the two different ways to use cutter compensation or contact contour. With CSE we support both mechanisms, and I will show you how to switch between both shortly. So first of all, I will create a short ANSI program to be able to test our cutter compensation, and then we should implement it. So first of all, I'll get rid of some of the old stuff. So we should define our zero offset. We activate the zero offset. Then we should change a tool so that we have a tool in the spindle, otherwise it doesn't make huge sense to do zero offset. And then 0, 0, 0 is then here the lower left corner of our box. The box is 100 millimeters high, and I would like to use cutter compensation to really go around the part rectangularly. So first of all, I will move to set 100. This should be now exactly this position. And since I would like to activate cutter compensation, I need to go a little bit in X direction next to the part. So let's go onto the safe side, minus 100. In the end, I will use contact contour, so I will program the actual contour that I want to see. So in this case, the next coordinate would be to move to, so I need to activate cutter compensation, and in this case I want to go around against the clock. So I need to offset, if my toolpath is actually the line, I need to offset to the right hand side of the workpiece, and I can never remember, but I think to the right side is G42. We could look it up in the Siemens documentation, but I think this should be correct. So we activate radius compensation to actually compensate for the first time. We should move to G0, X0, Y0. I don't need Z again, Z is already 100. So then we are in this coordinate, but already with active radius compensation. Then I will move to X, and then we can switch to feed rate to X 200 with some feed rate, then to Y 200, then back to X0, and then back to Y0. So we go here, that's X200, Y0, then Y200, then back to X0 and back to Y0. And then we should deactivate radius compensation and move out of the part again, and probably do that with G0. So that is the test program that I would like to test. So we need to implement G42 and G40. To do that, we should first look into the documentation and find the correct section. There's an extra section about tool radius compensation. And the first one is set tool radius correction mode, whether we want to activate it or deactivate it, and if it should be to the left side or to the right side, and if the tool radius compensation is modal or non-modal. We had this before, for example, with the feed. So that's just defines if G42 stays active in the following blocks, which is the case on the Siemens controller. So then we can start implementing it. So I will create a new G code, G42. Oops. Press enter, sort it, and then customize it. A new command with the name set tool radius correction mode. One parameter is, the first one is if we want to activate it, and I guess this one is of type Boolean, so G42 should activate compensation. And the second one is left-sided, and since we said G42 should be right-sided, this flag needs to be false. And the modal flag, let's quickly check what is the default. So the default is that the radius correction in CSE is modal, so we don't need to specify the third parameter. So that's the implementation for G42. Yes, we can already copy it and make a G41. Edit. And the only difference that we'll have here is that the second parameter will be true, since in this case it's really left-sided. And finally we need a G40. Oh, G40, not 50. To deactivate it again. In this case it's false, and then I don't think I need the second parameter, so I think we can just remove it. Okay, Let's see if our program is correct and if radius correction is working correctly. Set and start to simulate. So we why does the tool change not work? To save my cam part yesterday, so I don't have a tool anymore. So I need to create a new tool. Yeah, the dimension is okay. And click OK. Just put it under pocket 1, and then it should inherit the tool number, should find it. And hopefully that works now. Simulate again. Yeah, this time we have a tool. So we are now moving to this position. Why here? Is my Z100 not correct? Ah, no. I don't have a D1, so our tool length compensation is not yet active. So we can either program that here after the M6, but like I told you in the section about the tool length compensation, typically the length compensation on the Siemens controller is activated already in the tool change subprogram. So we can try to locate our tool change subprogram and just add the D1 to activate the length compensation directly there. So let's locate that in Mach, resource, library, machine, installed machine, Sim8, CSE, Cinemeric, and subprogram. Open the tool change, and at the end just write D1. And then now my tool length compensation is active. And now let's see what happens if I'm executing or now moving to X0, Y0. And then you will see that we are moving to X0, Y0, but obviously without radius compensation. And that is by default CSE or ISV actually by default CSE uses the cutter compensation mode and not contact contour, and in this case we have defined the coordinates as contact contour. For integrated simulation, so if you have a post processor that posts operations on the fly, for this case we take the information whether the customer wants to have contact contour output or cutter compensation output. We take that from the operation. Since we now do simulation of externally created ANSI files, we don't have any operations. So in this, the ISV options, if you simulate from external file, they contain an option where you can switch on that you want to have cutter compensation to be interpreted as contact contour. And in this case, ISV will show a different behavior. So let's try it again. And in this case it seems to be correct. We are moving to the same coordinates, but our tool is correctly offset from the part. And you've already seen, or you can see here, that CSE reads ahead. So CSE has figured out that the next block will be in X direction, and therefore it has figured out that it needs to offset the tool in X direction. And then we can just fin part and round it. That's exactly the corner. And then deactivate it and move out again. That's it about cutter compensation. One additional thing here, I can probably show that in the PowerPoint. On many real controllers, it depends on the controller what is the behavior in the corners. So in this case, there are a couple of options, and what you've seen as a default in ISV is that CSE extends the curves until here and then moves from here. So you basically get a rectangular corner. Other controllers have this behavior that you get a transition circle, so that for the cutter compensation a transition circle is inserted automatically. For the Siemens controller you can configure this behavior. So with G450 you get intermediate circles, and with G451 you get this intersection behavior, and the intersection behavior is the default that we've just seen in simulation. But we can implement the G450 behavior to see if we can get transition circles. So to do that we need to change our ANSI program and somewhere write G451. Is this correct? No, 450 circle. Save it. And of course we need to implement that in our MCF file. So in this case you find a command for that is called set radius correction corner mode, and it allows you to specify whether it should be linear to create intersections or to create circles in between. So we will use this command and use machine configurator to generate the G450 command. Set radius correction corner mode, and one parameter, and that is of type string, and it should contain circle. Okay, yes, and let's directly create a copy, G451 with the option linear. Okay, save it. And simulating. In this case we're activating this circle mode. For the first coordinate still nothing happens. We should see a difference on the second coordinate. In this case CSE moves until here. And then let's try to see how we can zoom in so that you can see it. And then let's execute the block, and then you should see the beginning of the move, the circle that CSE has inserted automatically. And also here, let's make it a little bit slower. You can see the transition.